JAMB candidates, you are welcome to today's lecture continuation, and we are looking at alkanols or alcohols. Okay, remember that alkanol is a functional what group. Okay, it's a functional what group. So what are the classes of alkanols? Alkanols have three classes. Okay, the first class is the primary alkanols, the second class is the secondary alkanol, and the third class is the tertiary alkanols. What are their what? How do you differentiate them? Why are they referred to as primary alcohol or secondary alcohol or tertiary alcohol? Why? Let's find out why they give them that name. For the primary alcohols, the hydroxide, this hydroxide bond is attached to carbon that is bonded to one other carbon. So the carbon atom that this hydroxide is attached to is bonded to one other carbon atom. So when you see a structure that the hydroxide is bonded to a carbon atom that is also bonded to another carbon atom directly, it's a what? It's a primary alcohol. Okay. Then for the secondary alcohol, the hydroxide is attached to a carbon bonded to two other carbons. Okay. So this hydroxide is what? Is attached to a carbon atom that is bonded to two other carbons. Unlike this one, this primary that is attached to a carbon atom that is bonded to just one carbon atom. All right. Then let's look at the tertiary. For the tertiary, the hydroxide is attached to a carbon atom that is bonded to three other carbons. As easy as that, easy peasy. So for primary alcohol or primary alkanol, is you have what? One carbon atom. The carbon atom that the hydroxide is bonded to just one carbon atom. While for the secondary, the carbon atom is bonded to what? Two carbon atoms. Okay. While for the tertiary, the carbon atom that the hydroxide is bonded to is also bonded to what? Three carbon atoms. How do we form alcohol or how do we form alkanols? One of the most famous group member of the alcohol family is ethanol. And how do we form ethanol? Ethanol is formed through the fermentation of sugars. For example, you ferment palm wine to form what? Gin. Gin is ethanol. So palm wine is the source of the sugar. This is facilitated by microorganisms. Okay? They ferment. Okay, you also have another microorganism again that is also used for fermentation called Saccharomyces. All right, different species of the Saccharomyces. For example, Saccharomyces cerevisiae. So they are used to facilitate fermentation, the conversion of sugar to what? To alkanol. So fermentation, in essence, fermentation can be defined as the conversion of large molecules to smaller molecules. So during fermentation, we are breaking down large molecules such as polysaccharide, starch, to form what? Ethanol. Okay, that's fermentation. Ethanol can also be produced from petroleum byproducts, such as dehydration of ethene. Okay, dehydration of ethene to form ethanol. Okay, subjecting of what? Of petroleum product to high temperature. It undergoes hydration, is fed with what? You add water to it. It accepts the hydrogen, and what? Ethanol is formed from the hydration of ethene. Now, what are the importance of ethanol? Ethanol is used as fuel because it's very, very volatile. Okay, for machineries that uses volatile fuel, ethanol is suitable. Ethanol is also an alternative energy source. All right, ethanol is also used to make methylated spirit. Okay, yes, for antiseptic. Okay, ethanol is also used, and so on and so forth. Now let's look at the chemical reaction of the what? The OH group or the ol group or the alcohol group or the alkanol group. Okay, they undergo oxidation. Inside these three classes or the three groups of alcohol or ethanol is their oxidation that distinguishes them. Okay, how do you distinguish them chemically? It's through their oxidation, how they oxidize. Okay, for example, the primary alkanol oxidizes to aldehyde first, that's to al. For example, primary alkanol, okay, oxidizes to what? To alkana. Okay, then from that alkana or aldehyde, it oxidizes further to what? Carboxylic acid. All right, or to an acid. All right, so for primary alkanol, it oxidizes to what? To alkana or to aldehyde. Then it oxidizes finally further. Then it oxidizes further to what? Carboxylic acid. Put that inside your head. We'll jump the set question from here. Where? For secondary alkanol, it oxidizes to what? Ketones. You're going to get something like acetone. You're going to get something like ones, alkanones. Okay. Then for tertiary alkanol doesn't oxidize at all. They are resistant to what? Oxidation. Okay. Alkanol or the OH or the ol group or the alcohol group also undergoes dehydration reaction. Okay. Alkanol is dehydrated with tetrasulfuric acid to yield alkene at what? 1200 degrees Celsius. Alkanol is dehydrated by a dehydrating agent, tetrasulfuric acid, to form what? Alkene or ethene. Okay. Remember, ethene can also be hydrated to form alcohol or ethanol. Remember what we just discussed earlier. Okay. Now, what is the test for the various alkanols? Okay, or the various group of alkanol, primary, secondary, and tertiary. What is the test? It is done through the Lucas test. So the Lucas test is used for testing alkanols, the groups of alkanol, whether primary, secondary, or tertiary. Okay, the Lucas test differentiates primary alkanol from secondary alkanol or from tertiary alkanol by the rate of what? Turbidity. What is turbidity? The rate at which it what? Hardens. The rate at which it what? Hardens. Okay, that's what determines the particular group of alkanol. Okay, for secondary alkanol, it produces turbidity within 5 to 10 minutes. The reaction hardens between what? 5 to 10 minutes. Okay, for tertiary alcohol, it produces turbid cloudy layer of what? Alkyl halide. It produces what? Turbid cloudy layer of what? Alkyl halide. Okay, what is halide? You know what halide is now? Like chloro something. Part of the halogen family. Okay, halide. So let's say the alkyl, for example, is ethene. That's the alkyl group, for example. So what is a halide of ethene, for example? A halide of ethene is like chloroethene. All right. So chloroethene is a halide of ethene. All right. So it yields a cloudy layer of alkyl halide. So the cloudy layer is as a result of the what? The formation of this alkyl halide. Then the primary alkanol, no reaction at room temperature. No reaction to the Lucas test, the Lucas reagent. When you add the Lucas reagent, there is no reaction, no turbidity at all for primary alcohol. You don't see how the thing can change now. Okay. When we talk about oxidation of the alcohol. Okay, now the tertiary alcohol now no get any oxidation at all. It's resistant to oxidation. But during the test, using the Lucas reagent or the Lucas test, it is the primary alcohol or the primary alkanol that has no reaction at room temperature. The secondary produce turbidity between 5 to 10 minutes. The tertiary forms what is called alkyl halide and it appears cloudy. Okay, that's the kind of turbidity it forms. Okay, now let's look at the polyhydric alkanol. Polyhydric alkanol are the alkanol that has more hydrogen. Okay, more hydrogen in it. For example, it's like glycerol. Okay, and glycerol is part of the third group of alkanol, which is known as the tertiary alkanol. Okay, and this polyhydric alkanol or the glycerol is used in cosmetic, it's used in manufacturing soap, it's also used in manufacturing explosives. Let's look at alkanal versus alkanones. Remember, alkanal are the what? The aldehyde or the R. You can see the color code. R, they are the aldehydes. On, they are the ketones, ending in on. That's their what? Their suffix. All right. Let's do. I always say that anytime you see verses, just know that we are trying to compare two. Okay, we are comparing alkanal and alkanones. All right. So what is their distinction? What is their differences or their difference? Okay, alkanal has the group. Okay, their functional unit CHO, one double bond up to what? To oxygen. That's for alkanal. That is what usually ends their chain. One double bond towards to oxygen. Then the other one towards hydrogen. That's what usually ends their chain. Therefore, alkanol at the middle, okay, at the middle of the chemical compound, the structure, you are going to see CO at the middle. Okay, C bonded to O, double bond to O. C double bond to O at the middle, okay, of the group. I'm going to show you some of the structures, okay, when we start treating calculation in chemistry. All right. So, what is the chemical test for both alkanal and alkanone? Now, these things JAMB say make you know. Now, I make my notes be like this. Now, wetin JAMB want make you know I select give you. Okay, the chemical test include alkanals reduces Fehling solution / Tollens reagent. Okay, you are going to see a silver mirror appearance for alkanal. So Fehling solution and Tollens reagent. That's for what? Alkanal. So alkanal reduces Fehling solution and Tollens reagent, giving a silver mirror appearance. All right. So for alkanone do not have any reaction with this Fehling solution or Tollens reagents. No reaction at all for alkanone. It's only alkanal that is able to react with Fehling's solution or the Tollens reagents and give a silver mirror appearance. Let's look at the alkanoic acid or the carboxylic acids. Okay, so what is the chemical properties of carboxylic acid? Carboxylic acid such as ethanoic acid, for example, undergoes neutralization reaction, whereby it reacts with base to form salt and water. Though it's a weak acid, carboxylic acid is a weak acid. Carboxylic acid has many hydrogen, but inside all the hydrogen it has, it is only one, okay, that it can donate in an aqueous solution. It is only one that it donates as proton, okay, to form an aqueous solution, okay, making it a monobasic acid. Alkanoic acid or ethanoic acid is a monobasic acid, despite having multiple hydrogen atoms. All right. So ethanoic acid or alkanoic acid also undergoes esterification with alcohol, whereby you react alkanol with carboxylic acid or alkanol with ethanoic acid to form ester. That's esterification. Reacting with alkanol or ethanol with carboxylic acid or ethanoic acid, ester is formed. And What is ester? Now so ester dey be na ethyl ethanoate, propyl propanoate, ethyl acetone, and so on. So examples of alkanoic or carboxylic acid include ethandoic acid, which is also referred to as oxalic acid. And example of oxalic acid is dicarboxylic acid. So dicarboxylic acid is an example of ethandoic acid. And this ethandoic acid is an example of what? Carboxylic acid. So dicarboxylic acid is a kind of ethandoic acid. You have benzoic acid too as an example of carboxylic acid or an example of ethanoic acid. And aromatic acid is an example of benzoic acid. So benzoic acid is a type of carboxylic acid and aromatic acid is a type of benzoic acid. So benzoic acid are aromatic acid, ethandoic acid are dicarboxylic acids. Then in another way, in another pattern, in another style, ethandoic acid is an alkanoic acid. Benzoic acid is also an alkanoic acid. So you can see the tree, okay? The tree starts from this alkanoic acid. Down, it gives rise to what? Ethandoic acid and benzoic acid. Then from benzoic acid and ethandoic acid gives rise to their what? Their, you know, their omomo, their children, their carboxylic acid. This one is to what? Is to ethandoic acid. While for benzoic acid, you have aromatic acid as the what? The family. It join benzoic acid. This one, the carboxylic acid join ethandoic acid. As simple as that. Now let's look at the alkanoids, or they are also referred to as esters. All those ones where they carry OH, where they end with OH, the functional group OH. Hope you remember the tribal mark of the OH family, or the functional group where they call OH. You know the tribal mark, you know how they be, how they bonded. C bonded to what? Alkyl group, one alkyl group here, another alkyl group here. There's C bonded to what? Have that at your fingertip. So how are esters formed? We've talked about this before. It's formed through esterification, whereby you react alkanoic acid plus alcohol or ethanol to form ester. That's how ester is formed. All right. The natural sources of ester are fat and oil. They are found in fat and oil. Now make it use and they make soap. Okay, fat and oil. Ester of glycerol plus what? Fatty acid. This fat and oil soap is an ester of glycerol plus fatty acid. Remember, the final product of digestion of fat and oil is glycerol and fatty acids. Hope you know that. All right, I already taught that in biology. Saponification. I told you that ester is used to make soap. Okay, saponification is the manufacture of soap. Okay, the hydrolysis of fat and oil with alkali to form soap plus glycerol. Okay, what is the glycerol form? Propan 1,2,3 triol is the glycerol form. So when you hydrolyze fat and oil with alkali, such as sodium hydroxide or potassium hydroxide, depending on the alkali choosing, you are going to get soap and propan 1,2,3 triol. Okay, which is our glycerol. Okay, margarine. Okay, which is what? The hydrogenation of oil. Margarine is gotten from the hydrogenation of vegetable oil. And this hydrogenation of vegetable oil, what is the catalyst used? What is the catalyst used during the hydrogenation of vegetable oil? Remember, ester is oil. Abi, ester is found in fat and oil. So ester is used to make margarine. Ester is used to make butter. Margarine is butter. Okay, it's used to make butter through hydrogenation of ester or hydrogenation of vegetable oil at a very high pressure and temperature. Okay, so there is a catalyst used during this process. Okay, what is that catalyst called? Drop it in the comment section. We already treated that. What is the distinction between soap and detergents, or what is the difference between soap and detergents? JAMB say make we know them, make we dey accustomed to them. Okay, soaps are salts of fatty acid. They are biodegradable. That means they can be acted upon by bacteria. What does biodegradable mean? It means that they can be acted upon by microorganisms to form what? To form simpler molecules or simpler substances that are what? Less harmful to the society. Okay, so biodegradation occurs naturally. It means that it can naturally be acted upon by microorganisms to what? To form simpler molecules or substances that are less harmful to man and the environment. That's soap. So soap is natural. Salts of fatty acid that are biodegradable. But for detergents are synthetic. You know what is synthetic being? Artificial. Okay, they are synthetic. They are artificial. They work in hard water. Soap you can't use soap to wash in a hard water. You know if you use them, you know foam, it will not form lather. Soap can't do that. We've treated hardness of water. So if you've taken my lecture on hardness of water, this one's supposed to be like my mind for every day. Difference between detergent and soap. So detergents are synthetic. Many detergents are non-biodegradable, meaning that they can be acted upon by microorganisms to form simpler substances that are less toxic. All right. So, but modern day detergents are biodegradable. Modern days detergents are biodegradable. Yes, many of them are biodegradable. In fact, most of them now are biodegradable. All right. And you can use detergent in hard water. It's going to form lather. It's going to foam. You can use it, but you can't use soap in hard water. So just know that soap is formed from what? Salts of fatty acid. It's natural. Okay. Detergent is what? Is what? Artificial, synthetic. Okay. Soap is biodegradable most of the time, but detergent, you can have the ones that is biodegradable and the ones that are not what? Biodegradable. All right. Soap cannot be used together with hard water. It's going to form what? Scum. Okay. It's going to form scum. Okay. It will not form lather. It will not foam. But detergent, you can use it in hard water. It's going to form lather. It will lather well with hard water. Now let's look at the amines. Okay. Or they are also called the alkalamines. All right. What are the classes of amines? Amines are divided into three classes. namely the primary amines, the secondary amines, and the tertiary amines. How do we differentiate the primary from the secondary from the tertiary? Just know that amines, they are usually called amines because they have nitrogen. They are nitrogenous compound. You know amine, amino acid. For example, amino, because it has nitrogen inside. That's why it's called amine most of the time. The primary amines attaches to one carbon with what? Nitrogen and 2 hydrogen atoms. 1 nitrogen atom and 2 hydrogen atoms. Okay, attaches to what? 1 carbon atom. Okay, that's for the primary amine. Then the secondary amine is just NH. 1 nitrogen atom and 1 hydrogen atom. They both attach to 2 carbon atom. Okay, 1 nitrogen atom and 1 hydrogen atom both attach to what? 2 carbon atoms. All right. Then for the tertiary amine, you have just 1 nitrogen atom attaching to what? 3 carbon atoms. All right. So just have it in your mind. Very simple. That for the primary amine, you have the NH2 attaching to just 1 carbon atom. For the secondary, you have 2 carbon atoms. The thing now, the NH is attached to 2 carbon atoms. Okay. While for the tertiary, you have just 1 N, which is just N, attaching to 3 carbon atoms. That's, you see 3 carbon atoms attaching to it. That's the tertiary. So JAMB is going to bring it for you. They will bring a structure, a structural formula of an amine or an alkalamine for you and ask you which of these is a primary amine, or what you have here, the above diagram is A primary amine, B a secondary amine, C a tertiary amine, D they will find another thing put for there. What's the answer? All you have to do is to look at what? How many nitrogen and hydrogen atoms they. How will they bond? It bonds to 1 carbon atom, I be bond to 2 carbon atoms, I be bond to 3 carbon atoms. That's how you know. It's very easy. So just know primary amine bond to 1, secondary amine bonds to 2 carbon atom, tertiary amine bonds to what? 3 carbon atom. As easy as that. What are the uses of amines and alkalamine? They are used to manufacture dyes, drugs, and also polymers. Now let's look at carbohydrates. Carbohydrates is the compound of what? Carbon and what? Hydrogen. Now make they call it carbohydrates. Carbon and hydrogen. Alright, you have the monosaccharide and the disaccharide. Monosaccharide includes glucose, fructose, and galactose. Those are the 3 monosaccharides. Disaccharide includes what? Sucrose, maltose, and what? What's the final one? Lactose. While polysaccharide includes what? Starch, cellulose, and so on and so forth. You have hemicellulose, you have lecithin, and so on and so forth. There are many. What are the tests for simple sugars? Okay, the tests for simple sugars include Benedict's / the Ferlin solution. These 2 solutions or these 2 reagents, now be waiting to take the test for simple sugar. Okay, and both of them gives brick red precipitates. Both of them, if you add simple sugar to the both solution, they give brick red what? Precipitates. What is the reaction of carbohydrate with concentrated tetrasulfate 6 acid? Like I said before, when you dehydrate it, dehydration reaction, you get a carbon black residue. When you dehydrate carbohydrates with tetrasulfate 6 acid, you know tetrasulfate 6 acid is a dehydrating agent. It is a what? It is a what? Hygroscopic substance. When you dehydrate what? You dehydrate carbohydrates, you are going to get a carbon black residue. Okay. Hydrolysis. When you hydrolyze starch, what are you going to get? For example, you hydrolyze starch present in cassava, you are going to get glucose, like I said before. When you hydrolyze cellulose, so both of them now, we are hydrolyzing polysaccharide. So it's trying to tell you that when you hydrolyze polysaccharide, you get glucose. So the hydrolysis of polysaccharide will give you glucose. So it will give you what? A monosaccharide. Now let's look at the uses of carbohydrates. Sugars. Sugars are used for alcoholic beverages. They are also used in pharmaceuticals, making of drugs. You know some drug where you see they will use sugar take coat am because they bitter well, they coat am with sugar so that you will feel easily ingest them. And sometimes they coat am with cellulose, so that if it's a drug that they don't want it to dissolve as the upper part of your GI tract, your gastrointestinal tract, maybe they want the drug to start dissolving in your small intestine. Okay, they don't want the drug to dissolve in your stomach, or they want the drug to dissolve in your stomach. They don't want it to start dissolving from your esophagus. They will coat it with give it a gelatin coat or give it a cellulose coat, okay, to prevent that from occurring. So starch is used in textile. I know say you don't first starch your cloth before now, or you don't first see cloth with starch where they make am stand, it will stand. So now starch they do one. It's also used in food industry. You eat starch now. Starch is your source of energy. It's your source of carbohydrates. Most of the food where you chop, spaghetti and starch, they there now. Your akamu, your custard, all those ones now starch now. Now that we have understood carbohydrates, the types of carbohydrates, the classes of carbohydrates, the reaction, chemical reaction involving carbohydrates, hydrolysis and dehydration, the uses. Let's now take some JAMB must repeat question 2. Test the knowledge we've acquired so far, and also measure our preparedness for JAMB UTME. JAMB must repeat questions. Question 303. Which of the following is a primary alkanol? A. Propan 2-ol. B. Propan 1-ol. C. 2-methyl-propan 2-ol. D. Glycerol. What's the answer? I just taught you this now. Remember, how do we differentiate a primary alkanol from a secondary alkanol from a tertiary alkanol? How do we do that? Use that style. All you have to do, draw all this structural formula. Draw the structural formula of ABC. D no just join. So draw the structural formula of ABC and you get the answer. You are going to know if the one that is a primary alkanol or a secondary alkanol or tertiary alcohol. Question 304. Ethanol can be produced industrially by what? A. Fermentation of starch. B. Hydration of ethene. C. Hydrogenation of ethane. D. Oxidation of methane. What's the answer? This question is my mind. Can I see you drop the answer in the comment section? Question 305. A local example of ethanol production is what? A. Gin from palm wine. B. Soap from palm oil. C. Nylon from petroleum. D. Detergent from benzene. What's the answer? Drop the answer in the comment section. Question 306. Which alkanol is polyhydric? A. Methanol. B. Ethanol. C. Glycerol. D. Propan-2-ol. What's the answer? Can I see you drop the answer in the comment section? This is more now. I taught you now. Do not disappoint me, please. Question 307. The Lucas test is used to distinguish what? A. Aldehyde from ketones. B. Primary, secondary, and tertiary alkanol. C. Alkanes from alkenes. D. Monosaccharide from polysaccharide. What's the answer? Can I see you drop the answer in the comment section? This is a very easy question now. Go and blast. Question 308. Primary alkanol on oxidation gives what? That's you are trying to tell us that the oxidation of primary alkanol gives what? A. Ketones. B. Aldehydes to acids. C. Esters. D. Amine. What's the answer? Drop the answer in the comment section. Question 309. Secondary alcohol on oxidation yields what? A. Aldehyde. B. Ketones. C. Acids. D. Esters. This is very easy now. I want you to go and blast. All these my JAMB repeat questions. You must see them. Drop the answer in the comment section to know you are ready, to test your preparedness, to test your readiness. Question 310. Tertiary alcohol are resistant to what? A. Neutralization. B. Oxidation. C. Esterification. D. Dehydration. What's the answer? Drop the answer in the comment section. Question 311. Which test distinguishes alkanals from alkanones? A. Lucas test. B. Fleming/Tollings test. C. Bromine water test. D. Iodine test. What's the answer? I know you know the answer to this question. Now give me the answer. It's very easy. As you look me now, so we look this answer for here. Now it's very easy. Drop the answer in the comment section, my scholar. Question 310. Alkanals reduce A. Fleming solution. B. Benedict solution. C. Tollings reagent. D. All of the above. What's the answer? Can I see you drop the answer in the comment section? This is very easy. If you don't even know the answer, you can use analytical skills found in the book 72 Hours to JAMB UTME. That's why you have to get that book. In this kind of question, even though you don't know the answer, you can use analytical skills and get the correct option. Drop the answer in the comment section. Question 313. Alkanoic acid reacts with base to form what? A. Esters. B. Salts plus water. C. Alcohols. D. Amine. What's the answer? Drop the answer in the comment section, my scholar. Very easy question. Too easy. Question 314. Esterification involves what? Acid plus base. Acid plus alcohol. Acid plus ketone. Aldehyde plus base. What's the answer? This is more now. This is a free mark given to you. Drop the answer in the comment section, my scholar. Question 315. Ethanoic acid is an example of what? A. Monocarboxylic acid. B. Dicarboxylic acid. C. Aromatic acid. D. Polyhydric alkanol. What's the answer? Can I see you drop the answer in the comment section, my scholar? Drop the answer in the comment section. Question 316. Benzoic acid is what? A. Aliphatic acid. B. Aromatic acid. C. Dicarboxylic acid. D. Polyhydric acid. What's the answer? Drop the answer in the comment section, my scholar. Very easy question. Question 317. Fat and oil are what? A. Alkanols. B. Alkanoids. C. Amines. D. Carbohydrates. What's the answer? Drop the answer in the comment section, my scholars. Question 318. Saponification produces what? A. Soap plus glycerol. B. Ester plus water. C. Alkanol plus ketones. D. Acid plus base. What's the answer? Very easy. Drop the answer in the comment section, my scholars. You are almost ready to blast your JAMB UTME. Question 319. Margarine is produced by what? A. Hydrogenation of oil. B. Hydrolysis of fat. C. Oxidation of alcohol. D. Neutralization of acid. What's the answer? Drop the answer in the comment section, my scholar. This is very easy now. If you can answer this question, that shows you are ready to bulldoze your JAMB UTME with your intellectual bulldozer. Question 320. Which of the following is a primary amine? A. CH3. B. CH32. C. CH3. D. NH3. What's the answer? I taught you now. I taught you easily. Think and drop the answer in the comment section, my scholars. If you can answer this question, that shows that you are almost ready to blast and bulldoze your JAMB UTME in 2026. Question 321. Carbohydrates are classified into what? A. Monosaccharide, disaccharide, and polysaccharide. B. Aldehyde, ketone, and acid. C. Alkanes, alkene, and alkyne. D. Amines, esters, and ethers. What's the answer? This is very easy now. This one will be marked the dash you. Drop the answer in the comment section, my scholars. Question 322. A test for simple sugar is what? A. Bromine water test. B. Benedict/Fleming solution. C. Lucas test. D. Iodine test. What's the answer? This is very easy now. Please give me the answer in the comment section. Let me know how prepared you are.